Yeah, a rollback? Yes. Somebody who's blinking? Hold on, everybody. Smile. All right, so I'm going to go ahead and start on time because it's about 2 hours long and I want to make sure we cram everything in before lunch. Just kidding. So I'm going to talk about virtualization and SAN basics for database administrators. And if you're here to think about Hyper-V, I want to start off by saying I'm not going to dive really deeply into Hyper-V. My personal favorite is VMware out of the two. Don't tell Microsoft I said that. But there's an excellent session after this by Alan Hurt, who is going to focus mostly on Hyper-V. So if you came here for Hyper-V, you're not going to hurt my feelings if you leave. Actually, you're not going to hurt my feelings no matter when you leave. I'm used to that. Make it louder? Yes, absolutely. Except I don't want to stare down on my jacket the whole time. Is that better? Is that better? Better? Can you guys hear me in the back? You know I can do too. Let's see if that helps too. Okay. So I'll be all self-conscious of that now. So a little bit about myself before we get started. I'm Brent Ozar, and I'm a Microsoft Certified Master, which if you were paying attention this morning on my blog, does anybody read my blog? Nobody reads my blog, do you? Oh, I love you people. So this morning Microsoft changed the Certified Master program, and a lot more people are going to be able to become Microsoft Certified Masters because you don't have to come to Seattle for 3 weeks anymore. Now you're going to be able to do some of this testing. I almost said from home, but you're not going to do it from home, but from a Prometric center. I founded SQL Cruise along with my partner Tim Ford. I'm my business partner. He's not my partner. My girlfriend will. She's gonna shoot me when she sees this video now. You have a partner? What? I'm an MVP, and I co-authored the book Professional SQL Server 2008 Internals and Troubleshooting. All 7 of us authors on that book are going to be doing a book signing today at 1 o'clock. So if you have that book, now's your chance to get a really good set of autographs on there so you can sell it on eBay and get back all that money that you wasted on that. Everything that I'm going to talk about today, when I talk about scripts or utilities, all of it is available at these 2 places, brentozar.com/go/SAN and brentozar.com/go/virtual. In addition to links to videos of me giving this talk in other places like SQLBits in the UK. And this is what we're going to talk about today. We're going to first start off with virtualization and talk about how virtualization changes CPU, memory, and monitoring. It changes a lot more than that, but just those are going to be the 3 things that we focus on for today. And then I'm going to talk about SAN guidelines, and I want to talk about why I'm so careful to not give you specific guidelines when I don't even know what kind of SAN you have or what your application usage patterns look like. But I want to start off with something very simple. So often, database administrators are so focused on how much overhead they lose in CPU or memory or storage throughput for virtualization. Your CIO doesn't care. If your SQL Server runs 4% faster, 4% slower, 10% slower under virtualization, he's okay with that because all throughout your time at your company, you've been saying the same things. I need more power. I need more power. And he knows that's not going to change even when he virtualizes anything. Throughout, as I talk about why we're doing virtualization, I want you to remember that virtualization is here to make things cheaper, not faster. Nobody says, boy, I just wish I could virtualize this SQL Server and all my performance problems would go away. Nobody says that. We're doing this for different reasons. And cheaper can mean less hardware, less software, less licensing, although in reality, almost none of these ever happen. Because it becomes so easy to deploy SQL servers or any kind of server in a virtual environment. You can just right-click and deploy servers from a template. You can go to your sysadmins who manage Hyper-V or VMware and say, I need a SQL server just for 2 weeks to test the new version of Denali because I just was able to download it from PASS. And he'll say, sure, he'll give it to you. And then you know what happens. You keep it running for the next 6 months while you play around with it. You go, I just need another 2 weeks. Everybody else in your company is doing exactly the same thing. And if you thought SQL Server sprawl was bad before, it's going to get a whole lot worse under virtualization. Your role as a database administrator is to embrace this cheaper and easier philosophy where you really don't have to have it the absolute fastest it can possibly be. It just has to be fast enough. And you have to make sure that you're not doing stupid things that would leave performance on the data center floor. And today I'm going to be telling you about some of those idiotic things that ship out of the box. It's not even our fault, but that just kill SQL Server's performance when we try to virtualize it. Now I'm going to start with a pop quiz. What CPU percentage does your CIO want to see? If he goes into Task Manager, what's the number he wants to see? You guys have figured this out, and unfortunately as database administrators, we're doing it wrong. This is what we want to see when we go into Task Manager. We want to see these nice zero-based numbers, with as little as possible, and we freak out when it hits 50%. Those days are over. And what's worse is in virtualization, this is really meaningless. Because if you go in and remote desktop into your SQL Server and you want to see whether or not things are okay by how high those bars are going, those bars don't mean you're using 100% of the CPU. It means you're using 100% of the CPU that's available to you at any given moment in time. Before, in the days of before virtualization, we would just ask, how many cores do we have and how fast are those cores? I got a quad core box, it's running 3 gigahertz, mine is bigger than yours. But after virtualization, we have to look at how many virtual cores do I really need? Because one of the dark and dirty secrets about virtualization is that the less virtual cores you have, sometimes the faster your SQL Server will run. Just because you're virtualizing a box that used to be running on a 2-socket quad-core sets of CPUs doesn't mean you need 8 virtual CPUs, especially if you were sitting around doing this, right? So I want to think about how fast is each of those cores and how many cores are really available to me at any given moment in time. And I'm going to illustrate this with something really simple that would never actually happen in the real world. I have a host that has 4 single cores, whether I want to think about it as 4 single core CPUs with 4 sockets in it or 1 quad core CPU. I've got 4 cores that I can use. And I only have 2 virtual servers running on it. I've got a SQL server named SQL, and I've got an app server named App, because I'm not creative. And mostly it just sits around idle. And when I want to do something with SQL Server, this is what it looks like. I've got 4 cores up and running on there, and SQL Server is using 2 of those cores. I keep forgetting I have the world's brightest laser pointer now. And if you ask a bad question, I'm going to aim it right in your eyes. If you ask a good question, I'll burn your neighbor. What's that? It's not red? Oh, because this is brighter. I'm red-green colorblind, and I just said, give me the absolute brightest one. It's a lot like if you ever ask why my clothes don't go together, it's the same thing. It's my laser pointer and my eyes. So when our SQL Server is working, so it's right now using those 2 cores over there, everything's going fine, my query finishes, and I get off those cores. And my Apple remote is not working. So now, all 4 cores are sitting around idle doing nothing. Now the application server wants to get some work done, and the hypervisor decides, I'm going to put him on these 2 cores here, because what difference does it make where I put him? They're all idle anyway. They're all just sitting around not doing anything. I'll schedule him on those first 2. The application decides that he's going to run a couple of queries in SQL Server. Now what happens? When the application is working, and now my SQL Server wants to get some CPU power, where should I schedule him? Where should I make the SQL Server run? Should I make him run over on these cores over here or these cores over here? Well, one approach is to just wait until that application server decides he doesn't need that CPU anymore. Why would I do that? Why would I choose that approach? Who knows? You're a smart guy, Robert, I know. I got a Microsoft Certified Master up in the front row right here, ladies and gentlemen. Robert Davis. So does anybody know why I would take this approach? You're caching, yes. So I might have something in the CPU cache of those first 2 cores that I might want to take advantage of. If I'm doing something computationally intensive, I put some real valuable data in there, and I don't want to have to go all the way out back to RAM, which sounds goofy that RAM is slower, but RAM is way slower than CPU cache. So if I think there's data that's valuable to me on those first 2 cores, I might say, you know what, I'm going to wait, and whenever that application server is done for a millisecond or a microsecond, I'm going to go ahead and jump in. Or maybe I decide to schedule him right away on those other 2 cores that are available, because I don't care whether or not I'm going to get a cache miss. I just want to start processing right away. This is really tricky. We've never had to worry about this before as database administrators. We just think about things like the buffer cache. It gets even more complicated in the days of Intel Nehalem. These are the latest Xeon chipsets. And I've got 4 cores here, or maybe more, depending on if I go AMD's route, for example. But notice that all 4 of them share the same L3 cache. So it doesn't matter which core I schedule it on, right? I could get him started working right away because everything is down in the L3 cache, but that's too simple for real life. In real life, we have hosts with 2 sockets or 4 sockets. And now my hypervisor has to be smart enough to know that if my SQL server ran over here on these first 2, it's okay if we run him over here on these 2 because his cache is here. But I don't want to push him off and schedule him over here. Ooh. We've never had to worry about anything like this before as database administrators. And it gets worse. Because another feature of these processors is that they will slow down if they're not being heavily used. The way most servers ship out of the box today with Xeons is that they have power saving set up in the BIOS so that those CPUs don't run 100% all the time. They go up whenever you're under really heavy load, but under virtualization most of the time, because you're switching in and out clock cycles, you're not under heavy load all the time. And even if you think you're doing it right, there are bugs out there with the way that this is implemented. And I'm going to pick on one vendor for a minute, even though I love HP, but they were just nice enough to actually come out with this bug. And blah, 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 support communication, customer advisory. Let's drill down a little closer. If a ProLiant DL385 GP is using the system ROM versions, the system may intermittently experience degraded performance. The degraded performance is caused by the processors running at the lowest power state. Well, that's not good. The processors will remain in the lowest power state regardless if the workload increase warrants an increase in the processor power state. The processor will display a frequency of only 800 megahertz. 800 megahertz. And after this condition occurs, the processor power state will not increase until the server is power cycled or until the system ROM is updated. And rebooting the server may resolve the issue. Whoa! So we just assume that when we go in and we buy a server that's 3 gigahertz or whatever, okay, sure, it's got power saving enabled. It's going to go up and down. It'll be able to be smart enough to recover. That's not necessarily the case, especially with Windows 2008 and its power saving features. I blogged about this recently. So the first thing that I want you to do when you're running under virtualization is and even for your physical servers out there that are new that are running Nehalems, I want you to get this completely free tool called CPU-Z from CPUID.com. And even under virtualization, it will tell you 2 very important things. One, what the specs, the box specs, what it says on the box, how fast your processor will go, and then the core speed that it's actually going. And very rarely are those 2 numbers the same when you didn't know about this. Once you know about this, you're going to go in and set the settings in the BIOS for your server to run full throttle all the time, and you're not going to tell your CIO that you're burning extra electricity power. You're just going to go and do it because you don't get bonused based on how green your data center is. Go ahead. Oh, yes, absolutely. So specification is how fast it should be running, and then core speed is how fast it's actually running. In this case, they're almost identical, but if you go to my blog, I've got some pictures of servers, including our ones at Stack Overflow, that were running well under half power. People think that if you run an intensive query, suddenly the server's going to speed up, and that's not how it works. The server has to run under sustained heavy usage for a while before it'll ramp up. We were running at 50 to 70% CPU load around the clock, and the server still wouldn't speed up. It still just said, well, you're not running at 100. Everything's hunky-dory. When you use 100%, I'll speed up. So under virtualization for SQL Server, we've got a few best practices that we want to do. First and foremost, I want to always use, is that man going to shoot me, or what's he got there? Yes, fire away. I couldn't tell you about AMDs because I don't have any customers using AMDs for under this for virtualization. But I have no clue. I would go find out though. I haven't seen any servers that didn't exhibit this problem bought from brand new because everybody wants to be green. Take the what? Take the feature out? Yeah. As a database administrator, I'm like, I want more power continuously. Any green power saving, whatever. Yeah, get it out of here. So these are the CPU best practices that I want you to use under virtualization. First off, you want to use the latest and greatest version of your hypervisor. Whether you're using Xen, Hyper-V, or VMware, every time it comes out with a new version, they are more aware of things like NUMA nodes and NUMA groups so that they put your SQL Server on similar cores than it was before in order to be able to reuse that CPU cache that you stuffed in there. Second, I want to minimize the number of virtual cores, and I've got a blog post up there under brentozar.com/go/virtual explaining why that is, along with documentation from VMware. And I want to check those CPU speeds in cache with CPU ID, and I always want to keep checking that because your sysadmins can move your SQL Server around from one host to another, and they might fix one host and not fix others. Or they might go buy new servers and not remember to set this. This is your job as a database administrator when you're complaining, why are my SQL servers so slow? And your CPU goes straight up to 100%, you may not even have that much power available to you. You want to strip out any unnecessary virtual hardware, so especially if you're running on older versions of ESX and you've got things like floppy drives and CD drives attached in your virtual machines. If you don't need them, yank them out, because the more that you have on each host, the more interrupts that are going to be involved. I want to remove all background services, and the first few that I have listed on here are kind of no-brainers. If I had $1 for every time I remote desktoped into a server and I saw Adobe Acrobat or the Google Toolbar installed on a server or Firefox because somebody said, oh, I'm surfing books online so much I want it to be a better experience, pull that stuff off, because every one of those is running an auto update agent in the background going and checking to see, is there anything new? Is there anything new? And I want to make every other virtual server do that exact same thing. The last one is a little tricky, and that's antivirus. In a perfect world, I wouldn't need antivirus on my SQL server, but I have problems like employees that I don't trust who go in and install Firefox, the Google Toolbar, Adobe Reader, and they're surfing YouTube and lolcats in the middle of the day going, I'm almost done with this production problem, give me another 5 minutes. So the reality is that most of my clients still require antivirus to run on the SQL servers, but I want to be careful with the settings because by default, most antivirus software pulls for updates fairly frequently. Now, it's a dirty world out there, so there's a lot of antivirus updates that come out. And when any antivirus software grabs new updates, it does a scan. Does a scan at least of this data in memory and on the OS drive, and quite frequently they will scan out through any other attached drives as well. So if you've got a SQL server that's doing dual duty, like as a web server and a file server, it's going to go out and scan the entire drive whenever that happens. Question in the back. That's a great question. He said, if the host machine is running antivirus, is it logical to run it in the guest? Yes. The host, if you're running Hyper-V as a server, VMware, this isn't an issue because there's not viruses on ESX. But if you're running Hyper-V, the root node will not catch viruses going on inside each of those guests. Go ahead, other questions. My vote is yes. The question was, should data files, log files, trace files, for example, backup files, should those be excluded from the scan? My vote is yes, because I've seen instances where the antivirus starts up faster than SQL Server and grabs a lock on a file. SQL Server, even though it's not long, when SQL Server goes to start and it can't grab that file, the database comes up as suspect. Even though the database is completely okay, it's just the antivirus is holding a lock on that file temporarily. It's not usually a performance issue as much as it is just an availability issue. The questions on antiviruses is always a hot topic. I have that covered, and as well as several other initial configuration things in my blog. If you Google or Bing, I suppose, to be politically correct, if you search for SQL Server Setup Checklist, I've got a detailed step-by-step article on everything I do before I install SQL Server and after I install SQL Server. And it's totally real world. It takes you only 15, 20 minutes max before and after you install SQL Server, and there's very real performance gains to be had from doing that. And then I want to monitor for throttling in other guests, and I'm going to get to how I do that a little later in the presentation. And I want to avoid affinity masking. If you've been around the block, like Robert Davis up here, the Microsoft Certified Master, you'll know that affinity masking is one of those tweaks you can make on an active-active cluster in order to help balance load more smoothly. I'm going to argue that you don't want to do active-active clustering inside virtualization. If you need fine-grained CPU control, the better way to do it is to isolate instances onto their own virtual machine instead. And you can't really predict which processor it's going to use inside affinity masking because your hypervisor can move that around. If you've never heard about affinity masking before, don't go learn. It's dead. It's not a good idea. Unless you do active-active clustering, in which case I love it. So now we talked about how virtualization changes CPU. Let's talk about how virtualization changes memory. So it's time for another pop quiz. Who can tell me exactly how much memory a SQL Server needs? More over here is the one I like even better. I like more even better than, usually I hear people say as much as you can afford. And I can say, no, that's not even enough, usually. The sad thing is, we're not very good at this. And it's a shame that in the year 2010, as database administrators, we don't have a better way of saying, here, this is exactly how much my SQL Server needs, and I know for sure if I have this, performance will be okay. CIOs got tired of writing checks to us, or to our vendors, in order to get more memory for our SQL Server. And so what they did was pull in virtualization, which will allow it to share memory between multiple guests. And here's how the magic happens. I've got a little legend in there where I talk about VM, XS, HV. So there's three things that we're going to do. This one, hypervisor dedupes and compresses memory, is only done by VMware in a Zen Server prototype, not in production for Zen Server yet. This one's done by all three of those platforms, and the last one is only pretty much done by VMware right now. So I want to explain each of those bit by bit. The hypervisor dedupes and compresses memory. If you've got a host, Hyper-V host, VMware host, whatever, and you're running 10 guests on it, and they're all running Windows Server 2008, there's a lot of duplicate memory in use by each guest. You got 10 copies of Internet Explorer running because, of course, you went and remote desktoped into each of those to watch YouTube. So we're putting the same pages in memory across all 10 servers. VMware and the Zen Server prototype, as they're sitting around idle, not doing any work, will examine the pages in memory and say, oh, I see 10 copies of these pages from the Internet Explorer DLLs, let's just say, that are in memory across all these at the same time. I'm only going to store one in memory. And now the rest of them get a pointer to the exact same page, but they don't get their exact same memory. Because the more servers that I run on a host, the odds are higher and higher that I'm actually going to have the same stuff in memory multiple times, but not with SQL Server. This is one of those apps that really frustrates the hypervisor guys because they say, why does SQL Server use so much memory and it doesn't go down and there's no deduping going on? Well, that's because if I've got 16 gigs of RAM in my SQL Server, let's just say, I've got a lot of interesting stuff in the buffer cache there, and just because I have another SQL Server running right next to it doesn't mean it has the same stuff in memory. It's got different databases which are going to bring in different pages into the buffer cache. Even if I have production and development on the same host, which is a bad idea, but even if I did that, they wouldn't have the same pages in memory because I'm constantly updating those pages on both SQL servers to have different contents in them. So that doesn't work very well for SQL servers. The next thing that the hypervisor will do is there's a balloon driver. You know those little tool installs that pop up after you build your little virtual server? It says install the VMware tools or install the Hyper-V integration services. They're installing a bunch of dirty, nasty little things, but the worst of them is called the balloon driver. Every minute, 2 minutes, 3 minutes, it sits in the background and says, I need more memory. I need more memory. I'm about to do something big. I need more memory. And it's just lying. It doesn't need any memory at all, but it's telling Windows, I want you to allocate me as much as I can possibly get because I'm about to do something huge. And all it's really doing is putting the OS under memory pressure so that no other applications will use memory. And applications like SQL Server, which is an absolute polite application that says, I hear there's memory pressure, I would be glad to give up some of my memory, and it will tail right down the amount of memory that it uses. And what's the default minimum memory setting for SQL Server? 0. SQL Server will just say, oh, I understand there's memory pressure. I'm going to give up some of this memory over here. Here you go. Here's all my buffer cache, my procedure cache. Hope you're having a good time over there. And meanwhile, SQL Server goes right down the toilet. SQL Server performance just, and we don't understand because our virtual server has 16 gigs of RAM or whatever, and we can't get SQL Server to use more than 4, 6, 8, whatever, because that other memory is not actually free and available. The Balloon driver has asked for it. You're going to ask a question? No! The question was, can't you lock pages in memory to alleviate that? No, because SQL Server is not going to grab all the pages necessarily immediately, and even when SQL Server is under memory pressure, it will give other things up. That lock pages in memory is the buffer cache, not everything else that SQL Server uses. So that's horrendous, and I'm going to talk to you about a way to fix that. The last thing is the absolute worst case scenario, which is what happens on your laptop whenever you go to open up TweetDeck, Outlook, Excel, Monster.com, Dice.com, all these places where you're surfing to find a new job because you're so miserable, or you're just emailing all your buddies who are coming to pass. Who knows a good recruiter? So as you're launching all of these things, all of a sudden your hard drive light pops up, and it's going like crazy, and your machine slows down because your boss was so cheap, he only bought you a laptop with 1 gig of RAM. How many people have just still 1 gig of RAM in their desktop machines? Oh, yeah, Andrea over there, yes. So you can, later, I'll tell you about like Monster.com and the other places. So it's swapping to disk. Your Windows is saying, you've got memory, but it's actually hard drive space. Now that's easy for us to see because the light is popping on for our hard drive, and when we go into Task Manager, we can see we have no memory available. Unfortunately, when your hypervisor does this, you don't know. When you go into Task Manager, it shows that you have 8 gigs of RAM. You don't know that the physical host only has, say, 4 gigs of RAM available, and your other 4 gigs are swapped out to disk. And the reason that you don't know is because you never measure memory speed. You assume, just like I always did, that whenever I'm accessing memory, it's going to be fast because that's what memory is. And that is dead and gone in the days of virtualization. So these are the ways that we're going to want to fight that. There's 2 sets of recommendations, one for VMware and one for Hyper-V. First off, under VMware, I want to set what's called a memory reservation for my virtual server. And I can't do this unless I'm the guy who owns the VMware Virtual Center permissions. More about that in a minute. But this tells your hypervisor, this is the minimum amount of memory I should ever be able to get. Let's say that I've got a virtual server with 16 gigs of RAM. Set me a reservation at 12 gigs of that, and that way the Balloon driver knows if I'm only using 12 gigs of memory, the Balloon driver doesn't pop up and say, I'd like some more memory, please. It just keeps quiet and says, oh, you're using what you have reserved, you're fine. I'm not going to ask for any more. But if you start using more than that, the Balloon driver is going to kick in when the hypervisor is under memory pressure and shove you back down to 12 gigs of RAM. Now, what reservation is right for you? Ask your doctor. But ideally, if I'm starting from a beginning negotiation point and my VMware sysadmin doesn't know enough about how reservations work, I want to reserve all of my memory. If I have a 16 gig virtual server, I want him to say, hey, go in there, right click on my virtual server, go into properties, and there's this reservation here. This should be 16 gigs too. Trust me, I heard it from a Microsoft certified master. He would never lie to me. Don't tell him I'm a consultant, because they know we consultants lie all the time, but never to you guys, just to other people. So that's the first thing that I want to do is set that reservation. But if he says, what's this number and why does it matter? Why is it not 0 like all the rest of my virtual machines? And you have to bargain. I'm okay with going as low as, say, 75% of my memory. But if it goes any lower than that, I don't think I really have that memory to begin with. He could just be selling me the Brooklyn Bridge and saying, oh, sure, your virtual server has 24 gigs of RAM, but I'm only going to give you a reservation for 8. Every time you go under memory pressure, my SQL server is going to lose all of its memory as it just gracefully gives stuff up. The second thing that I got to do is set SQL Server's min and max memory appropriately. The default of 0 is a bad idea. Go ahead and crank that up. My general recommendation is I want to go with 50% for the minimum. If I have a SQL Server with 8 gigs of memory, let's just say, I'm probably going to set my min at 4 gigs. If it needs to go any lower than that, I want to find out about it. Usually, in a physical world, it's because somebody else installed an application on that server, SharePoint, IIS, whatever, and that's pushing out memory. Next, I want to monitor to make sure they're not lying to me when I say things about how much my reservations are, and I'm going to cover that in the next slide. But finally, Hyper-V just is not announcing, but they announced last year at TechEd that they've got a new feature called dynamic memory that will automatically grow and shrink the amount of memory that you have available. Our DBA's immediate reaction when I say the word shrink should be panic! Panic, running, screaming. It sucks. I am not a very big fan of using dynamic memory for SQL Server. This is really a feature that's designed for dynamic virtual desktops. So when the CIO decides that you're not even going to get a good laptop anymore, you're going to get something with 1 gig of RAM, and you're going to connect to a virtual machine in the data center. Most companies aren't doing this yet, but that feature works great for that. And finally, if you are using Hyper-V, go to Alan Hurt's session immediately after this, although it's in a different room. For those of you watching on the internet, I guess there's no camera, they're not watching. I guess, for those of you who are watching on the internet. All right, so I said I want you to monitor to make sure that they're not lying to you. This has been tough because historically, Task Manager is all we've got. And we get so frustrated because it doesn't really tell us what we want to know. And there is something extremely awesome that's new in VMware. It's been out, it was a manual download under ESX 3.5, and it's new built into the box starting with vSphere 4.0. How many of you guys are using VMware? Show of hands, okay. How many of you guys are using Hyper-V? Okay, good. Robert, good. You know it's on camera probably is why you're, yes, I love Hyper-V. So there are new perfmon counters built into your guest that require no extra permissions, they cannot be shut off, and your VMware sysadmin probably doesn't even know they exist. So let's look at what they tell us. There's two sets. There's VMware processor counters. So the first tells me what the percent processor time is for each individual core that's on that host. This is much better than Task Manager because Task Manager only shows me what I'm using that I'm able to get, not what everybody's using altogether. If that host is pegged out at 100% CPU time, that tells me we got to buy better, faster hosts. And I would never know that unless I was able to see these perfmon counters. The second thing that I want to monitor is host processor speed. Sounds goofy, it should always be the same, right? Well, this has nothing to do with that power thing that I talked about earlier. What this is really because of is that under VMware, under ESX and vSphere, your sysadmins can move your SQL Server from one host to another in real time without you knowing if they set it up right, which hardly anybody does, but once they do set it up right, once they figure out, because you call them 5 times in a row, why did my SQL Server just lose all its connections again? They figure out how to set it up right, and then they can move these things around. And you want to know when you've been moved to a slower host. Because if all of a sudden your query performance time goes down, queries are taking longer and longer to execute, it can be because you were moved to a slower server to begin with. Next, I want to monitor for the limit in megahertz, and this is pretty much exactly what it sounds like. Your VMware sysadmins can set a cap on how much CPU power you actually get. So you might look like you have a 4-core, 3 gigahertz box, but they've set a limit on you to just use 1 gigahertz in total, and you don't understand when you go to do something intensive, all of a sudden your CPU goes straight to 100% and you're not even doing that much work. It's because they set a limit on you. I want to monitor this in perfmon and make sure that it's always 0, which means unlimited. As soon as that number is anything other than 0, that means you have to make a trip down to the flower shop and bring in some roses for your sysadmin to say, can you please tell me why you throttled my SQL server? Because you know they don't respond when we try to kick the door down. They just go, yeah, whatever. And then finally, I want to monitor for reservation, because after I put all that hard work into working with him and making sure that I've got a reservation on my SQL server, that it stays there. Because one of the beautiful things about VMware is that, not to keep pushing VMware, I also like Hyper-V, it's fantastic. And I'm not just saying that because Robert Davis is in the front row. But because they can set, if they set reservations across all their virtual servers and they go to power on another virtual server, VMware will say, your ego's writing checks your body can't cache. And it won't allow them to turn on another server because it knows that you've already set reservations for the entire amount of CPU available on that box. So what will your sysadmin do? He'll turn down your reservation so that he can boot up more boxes. So I always want to monitor that to make sure it doesn't change. So the second part that I want to monitor is memory. First off, I want to monitor, just like CPU limit, I want to monitor the memory limit as well. It's also nasty and dirty. They can give you a virtual machine with 16 gigs of memory, but they went, you're limited to 4. And you'll never know until you notice that the balloon driver is all of a sudden firing off all the time and your SQL server won't use any memory. Next, you want to check that memory reservation. I didn't tell you to set this to a specific number. Again, I just want to make sure that that doesn't change. And the last two are diabolical: memory ballooned and memory swapped. In a perfect world, I always want to see those at 0. If I see those as anything other than 0, my host is under memory pressure, and I'm starting to having to give up my memory or use disk for memory, which is an instant performance flush down the toilet. So I ranted and raved a lot about virtualization, and she's taking pictures of my slides for evidence. Oh no, she works for Microsoft. I'm just making that up. Okay, so the second thing that I want to talk about today is SQL Server on storage area networks. Time for our last pop quiz. Who here, by a show of hands, and it's always, there's like 2 guys in the back, right? And you're the SAN administrator too, right? Yes, exactly. That was why I originally got started doing SAN administration. The guy who was my SAN administrator before me kept saying, everything's fine on the SAN side. There can't be a problem. It must be a SQL Server issue. And then one day the guy goes up and quits, and I said, I would like that, please. I'll take those duties until you find somebody else, just because I want all the passwords and I want to go in and look and see what the performance is really going on. You don't have to pay me $1. I just want to find out if this guy was lying. He was lying. Unbelievable. So, shockingly, there is someone else who does not trust SAN administrators, especially your SAN administrators, your SAN vendor. They put all this work into building an amazing fast system, and your SAN admin is sitting there surfing lolcats all day, not doing his job, and performance is awful. And he's worried because when another SAN vendor comes in and says, my SAN is way faster, and it's just the same kind of thing, it doesn't cost much more, why don't you use mine? And of course it takes your boss out to golf, and so the next thing you know, you got a new SAN admin, and nothing changes. But your SAN vendor says, you know what, if I could just get the word out to people how to correctly configure their SAN. And of course, you've never seen these because your SAN administrator is not walking through the hallways handing them out to people going, here's everything I'm doing wrong. But I'm going to give you a preview of one of them. So this is, and all the vendors have them. I'm not praising IBM. Everybody does a pretty good job with this. So this sounds completely boring. IBM Mid-Range System Storage Implementation and Best Practices Guide. First, we provide a conceptual framework for entertaining the Tivoli Storage Manager. What's that? Well, they didn't capitalize the S in SQL Server, but we'll give them credit. At least there's the name of our product in here. So what do they actually talk about? Allocation unit size, RAID levels, disk drives, file locations. Oh, they're not going to get that specific, are they? They do. Look at this. RAID 1 or RAID 10 must be used for the database's TempDB and transaction logs. They didn't say should. They didn't say it would be really nice if. They didn't say in a perfect world. They said must be used. You've never seen this from your SAN admin, right? They go, RAID 5 is good enough for everything, you know? It's not. And the vendor is even saying, these are the guys who make this stuff are saying, don't do that. And there's similar documents out for every SAN. And they go into very specific stuff. User database files. Create the databases on a physically separate RAID array. No, not shared with the SharePoint team and the file server in your MP3 collection. Something completely physically separate. Consider the speed of the disks. Use the 15K RPM disks rather than the 10K RPM disks. Avoid using SATA drives for the databases. Now, there are cases when it's perfectly good to use SATA drives in databases. Is that where you were going to go? No.
Here's where I'm going to get in trouble.
Here's where.
RAID 5 can also be used, but with a slightly lower performance than the line that your SAN admin brings.
Absolutely. RAID 5 can also be used, but with a slightly lower performance. Data redundancy is critical in the operation of the databases. Absolutely. If they weasel down into that, I would come back to this and say, what's this? I would keep pushing them back. What about, I talk about that, and I don't know if I'm going to have enough time to cover it, but if I do, if I finish early, remind me, and I've got slides on it. Okay, that's cool. He was asking about, what about RAID 6, which is better than RAID 5, but extremely similar. So, we've never seen stuff like this before, right? We've never had this kind of ammo that we were able to go back and give to our SAN admin and kick him in the face and say, you're doing a really crappy job. So on that BrentOzar.com, I'm getting shot by more people. I don't know what it is. When somebody aims a camera at me, I can't help but make faces. Loved that as a kid, I guess. So I have on that BrentOzar.com/go/SAN, I have links to all the major SAN vendors and their lists of white papers that you can use to go to your SAN admin and say, you're doing it wrong. And it even has specifics like what your SAN admin means to do. This stuff probably means nothing to most of us, but when you go in there, you can say, hey, can you show me the segment size and the read cache and the write cache and the write cache with mirroring and the read ahead multiplier? Can you just go into the SAN tool and show me that so I know what you're doing? I'm sure you're doing it perfectly, but could you just show me because I'm not that bright? It's the approach that I like to use. Most people have seen my website. And what I do is on the website is I give you the exact URLs to Google for too, in case I don't have your particular kind of SAN and the way to pull that out. Now, there's tricks with this. I want you to look at the bottom one. Manually shrink the transaction log files rather than allowing SQL Server to shrink the files automatically. That doesn't mean you should shrink your files. Read it carefully and know as a database administrator, no, I'm not going to shrink my database files. It's just saying rather than allowing SQL Server to shrink the files automatically, which is a really bad thing. You don't have to do exactly everything that the vendor says, but anytime you deviate from it, you need to know and explain why. If your SAN admin says, oh, we're using RAID 5 and don't worry about it, it's okay. No, that's not good enough. Tell me specifically why you're not doing what the vendor recommended. Because me as a database administrator, it's really easy for me to say why we don't shrink files, and I've got all kinds of web posts I can go to saying, these are all the reasons I don't shrink my database files. And when it comes to picking evidence, I want you to use the coalesce statement in SQL Server. The way the coalesce works is it takes the first non-null value across all of the things that I passed to it. So if I pass in several values, it takes the first non-null one. Here's the way that you use advice on SANs. The first thing you should check is, do you have something that you have tested in-house and you know that works for your application? Don't just use RAID 5 because we think it's a good idea. Do performance testing, A, B, make sure that it works for you, or setting segment size, whatever. The second thing, if you haven't done that, if you haven't done extensive testing to know that that's the right thing to do, the second thing to look at is the vendor guidelines. What does your vendor say, your SAN vendor say, about your application, SQL Server, running on its hardware? The last thing you should ever use is general advice from bozos with blogs who stand up there and tell you to do things like always use RAID 10. That's the last thing you should use, and you should only use it if you can't find the other two. So if you can't find the other two, I'm going to give you some general guidelines, but I don't want you to think that there's this Microsoft certified master up here standing up here telling you that what I say is always right. What I say is the last thing you should look at. Go with what your vendor says for SQL Server first, because there are some SANs, for example, where RAID 5 is completely okay. So if you guys have a choice, do you choose your databases on RAID 5 or RAID 10? Because that's a common configuration question. Who has answers? You're all scared. Come on. Transaction logs for RAID 10, the data files for RAID 5. Somebody else over here said RAID 10. So here's the difference between RAID 5 and RAID 10. This is actually from my hometown in Chicago. This is I go walking my dog every morning in the park out in Grant Park, and I don't know what it is, but every morning this guy parks right next to me and rubs it in. And you should by now know that I'm not the guy in the back. I've always wanted a Porsche 911. Always, always, always. I want a Porsche 911 Targa. I know exactly what I want. I know what the interior looks like. The reality is, I drive a Honda Fit. Although I would like to point out that it's the Fit model with 5-spoke alloy wheels, just like the Porsche. And I have Tiptronic shifting. It's really quick. RAID 5 is good enough for me, and I've made the decision, and when I say RAID 5, I mean my Honda Fit is good enough for me for the performance that I need going back and forth to the shop. I can scare my girlfriend to death in a Honda Fit, let alone a Porsche 911. She wouldn't even let me get close to driving that thing to capacity. What RAID you pick usually isn't up to you. It's usually up to the finance people at your company. In a perfect world, I'm going to pick RAID 10 for absolutely everything because it's faster. But just like the Porsche, I can't always afford faster. So here's what I want to cut in the order that I want to cut it. The first thing that I want to do, initially the guy up front here said that you should put your logs on RAID 10 and your data on RAID 5, and that's absolutely correct. But the first thing that I want to sacrifice is TempDB. Because as a database administrator, when somebody tells me that their TempDB queries are slow, I go, yeah, exactly. Because TempDB is like a public toilet. You have no idea who else is in there at the same time as you, what they're doing in there, that it smells bad, it's hardly ever cleaned up. And these days, with SQL Server, each new version that they bring out is also using that public toilet for things like read-committed snapshot isolation, online index rebuilds. There's all kinds of things that are fighting with you in TempDB. And when my users complain about TempDB performance, I go, yeah, stop using TempDB. Get out of there. Or if you absolutely insist on using TempDB, okay, you have to go to the SAN admin and you have to tell him why you need RAID 10. Because he says it's fast enough. This is now your problem, not my problem. And whenever it's possible as a database administrator, I try to shuffle out of the way, just like the SAN admins do, going, it's not my problem. So I want to sacrifice those two first. The third thing that I would sacrifice is my user database data files. The difference between data and logs is that logs are always written to sequentially. Boom, 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 boom. The fastest I can do inserts, updates, and deletes is as fast as I can shove data through those log files, and sequential writes suck on RAID 5. Now, there's a dirty little secret with that, and I'm going to come back to that in a minute, but just in a perfect world, I'm going to put my data on RAID 5 before I'm going to put my logs on RAID 5. And finally, the last thing that I would sacrifice is my backup target. In so many organizations, people have one file share where all of their SQL Server backups are written to. All of their SQL servers write off to one share, and you know what the sysadmins think? It's backups so it can be cheap. We can just use RAID 5 SATA for that. In the back, go ahead. Is that the end there? Just want to make sure before I looked like you were going to keep going. So yes, and by the way, okay, so he asked, is there any benefit to breaking up TempDB data files in virtualization? Well, actually, you didn't say data files, but I'm going to break that into two things. Whether you're on physical disks or physical servers or virtual servers, the rules are the same for TempDB. The log files, you should only ever have one log file per database, whether you're using TempDB or user databases. One log file for database, period, and even one can be too many, which sounds really goofy, but if you wonder at all how your log files are configured, go to brenozar.co/go/fastlogs, all one word, fastlogs. And it's a link to a Kimberly Tripp blog post about VLFs, which is an issue with log files that if you had auto growth turned on and you had it set with 1 meg or 10%, that log file was growing and growing and growing in tiny increments, and you could be suffering performance problems even with just one log file. Now for the data files, TempDB data files, the general recommendations are out there in the field. There's two camps, one that says you should have one data file per core, and one that says you should have 1/4 to 1/2 data file per core, meaning if I have a quad core machine, I would either have 1 or 2 TempDB data files. Just so happens that one of the people who wrote one of those, the 1/4 to 1/2 rule, is my coworker Paul Randall at SQL Skills, so guess which one I'm going to recommend. Hi Paul, I'm sure he's listening. So yes, you want to start with 1/4 to 1/2 data file per core until you notice TempDB pressure. Then and only then do you go up to 1 TempDB data file per core, especially in the days now where people are buying 12 core CPUs, where a 4-socket 12-core box each, that's 48 cores. Do you really want 48 TempDB data files when you're not even under TempDB pressure? Probably not. You don't want to start that way. And then, so I was talking about backup targets. Backup targets, it's extremely important to write out as much data as you possibly can. That's all sequential writes all the time. And SATA is cheap already anyway. Typically, SATA RAID 10 will outperform RAID 5 of 15K drives if you're doing continuous large writes. So I'm really keen on, they're cheap, go with RAID 10 for your backup targets. And then finally, avoid RAID 0. Even if you think it's just TempDB, RAID 0 has no protection built in. It's just a bunch of disks. And if any one disk fails, the entire array is gone. So some folks have said, well, that's okay for TempDB because no data is stored in there. It's only temporary. Well, that's true, but when one fails, your SQL Server instance will stop if TempDB isn't working. And I don't know about you, but I don't want to get a phone call every time a drive fails and takes my SQL Server down. So I want to avoid RAID 0 unless I'm okay with an outage. So now let's talk about shared and, oh, go ahead. Oh. Yes. So there is I actually have an all-day training session where I go into SANS, and he was asking what happens with tiered storage, for example, when you have several tiers of storage available. That's a great topic, and I do want to dive into that. If you've got questions, come up, see me afterwards, and we'll talk more about it, because that's one of my favorite topics. I love that a lot. Any other questions before we go on? Go ahead. Thin provisioning. How do I feel about thin provisioning? So this is one of those cases where I want to say, talk with your SAN vendor, but if you can't get good guidance from your SAN vendor, I'll tell you what you do. Your log files should not be thin provisioned because your log files are sequentially written to start to finish. So if you've got a 100 gig log file, you're going to write the entire 100 gigs and then cycle again at the beginning. You're going to need, if you have a 100 gig log file, you're going to use that space and you're going to use it soon. So go ahead and provision your log files. So if you have your log files on a separate drive from your data drives, for example. For data files, I'm okay with thin provisioning. As long as you're, I know you go, the only reason I say I'm okay with thin provisioning is when your SAN guy says, how much storage do you need? And you tell him 3 terabytes, and he goes, okay, and you know he's only got like 500 gigs left available on the SAN. He did something called thin provisioning where he shows you a 3 terabyte drive letter, a LUN, and you don't actually have that space. And if you start writing that out, if you start restoring a huge backup, and your SAN runs out of space, your writes will fail. But if I'm building a new data warehouse from scratch and I know it's going to be around for 5 years, I might be okay with thin provisioning saying, go get me 10 terabytes worth of space now. Just know, keep an eye on how much space I'm using and continue to buy it as time goes forward. Go ahead. Yes. How do I feel about logs, SQL Server log files on solid state drives? They're fantastic. So there's three ways you can use solid state drives. One is vendors there's a vendor at the show, Fusion.io, that puts a PCI Express card in the server and has the solid state drive on there. That's awesome because now the solid state stuff lives inside your server rather than going out through the SAN cables, those fiber optic cables or iSCSI cables to your SAN, which means all the SAN, your TempDB traffic stays local and doesn't clutter up that path. So you have more throughput to your data and log files, which is important if you're doing things like big sorts and you need a whole lot of stuff in TempDB. You don't want to be fighting for that same path to the SAN. That's awesome for TempDB and for logs, but that doesn't work with clusters because then the PCI Express drive is inside the one cluster, or one node of the cluster, and there's not with clustering. You can mirror it, but not. Yes. It's fantastic for database mirroring. Absolutely love it. The other two ways that you can use solid state drives are you can actually buy a bunch of solid state drives, put them in a RAID 5, RAID 10, whatever, and carve out space for that. That's really expensive because SAN drives are way more than the stuff you see at Best Buy or Fry's. They're much more expensive on this. About a year ago, I was involved with a client buying a SAN, and for 1 terabyte of SAN space was $20,000 on average across several vendors. And we weren't even going with the most expensive vendor. I used to say that the Cadillac of SANs or whatever, and Cadillac's not even the most expensive cars anymore. The Bugatti Veyron of SANs. So that's another way to do it. The other way to do it is to just throw solid state drives in the SAN, and the SAN knows to use them as cache. So there are some vendors that will, anytime a write happens from any server, all the writes go to solid state drives. And that's a really fantastic technology, but only some SAN vendors support that. So if you've got questions on how solid state drives work in SANs, come up to me afterwards and tell me what brand of SAN you have or what brand of SAN your SAN admin told you had. It's Fisher-Price. It's the best they make. And then I'll tell you how solid state drives work with that. All right, so the next thing is shared versus dedicated. Now, when we were talking about log files, I said I wanted to put my log files on RAID 10. They wanted to be the last that I would play around with for slow speed. How many of you have one database per server? Not many of you. Most of you have multiple databases per server, right? 10, 20, 100 databases on a server. You probably have multiple users querying multiple databases at the exact same time, all doing inserts, updates, and deletes at the same time, yet all their logs are on one drive. Say it's the L drive, M drive, whatever it is. All their logs are on the same drive, and they're all writing simultaneously. That's not sequential. That's random. Because your SAN has to jump around and write logs for the sales database, the accounting database, the finance database, the lolcats database, the YouTube database, whatever it is. So when people get all hung up about shared versus dedicated, I want my SQL Server to have its own set of disks. Nobody else will touch them because that's so important. Log files must be on their own. Well, if you don't exactly know how many databases that you have and that they're being written to in a sequential fashion, I would argue you're already on shared storage. Because we put multiple databases, multiple log files on the same array, and that is random access. There's two concepts here, though. One is shared arrays. Should I use a big pool of drives shared between lots of servers and dedicate specific drives to specific servers? Or the other concept is drive letters, shared LUNs. Do I put my data and log files on the same partition when I go into Windows? So data and logs all on the M drive, N drive, whatever it is. And I'm going to address those individually. Shared versus dedicated arrays, which let's go back a slide and say, should I use one big pool of drives and just carve up individual spaces? If you have all of these, doggone it, Outlook just told me I had a meeting invite and I went to dismiss it. I'm not going anywhere today. If you have all of these, dedicated might be okay. The problem is, it's a lot easier to get dedicated arrays wrong than it is to get dedicated arrays right. Because what SAN vendors want to know is they'll say, how many IOPS do you need? I don't know. How many IOPS are you going to need 12 months from now? I don't even know how to measure IOPS. Most of us don't even know how to measure IOPS on our SAN server or our SQL service today. How on earth am I going to measure it, 12 months from now when we have different indexes, different query patterns? I can't predict that stuff. And so what we end up doing is say, I'll take 5 drives in a RAID 5. I'll take 8 drives in a RAID 10. And we are just guessing. We're taking shots in the dark. If we get it wrong in terms of not having enough drives, those drives are just hammered all the time and can't go any faster. And when we go back for budget for more drives, you know what the answer is? No. Whereas if we get it wrong the other way and we don't end up needing 8 drives in a RAID 10, those drives are just sitting around idle and you wish you had that throughput on one of your other drive letters. Like maybe you gambled wrong on the logs, or maybe you gambled wrong on TempDB and all of a sudden somebody turns on read committed snapshot isolation and your TempDB performance went down the toilet. Unless you have all of those and you're absolutely confident in it, and I already asked you who trusted their SAN admin and nobody raised their hands, shared pools of drives are easier to manage in terms of performance. If you don't get access to the SAN console and be able to go in there and micromanage performance all the time to make sure it's doing well, it's easier to get it right with a big shared pool of drives. Your SAN admin has probably been telling you this and you've been fighting. Most of the time they're incompetent, but this time they're right. This time we got to give them that much. Now, the other thing that I want to look at is shared versus dedicated LUNs. So if I have an M drive, let's just say that it's a terabyte, should I throw all of my databases, my data and log files on there? Or should I put one drive letter for my data files and one drive letter for my log files and another drive letter for TempDB? The real way to answer this is whether or not you're going to use SAN snapshot backups. SAN snapshot backups will let you back up no matter how big the databases are, will let you back them up nearly instantaneously in a matter of milliseconds. And this really does work. It sounds like smoke and magic. How could that possibly be happening? Well, the data's still inside the same SAN, so it's not really a backup. It's not making a separate copy. It's just saying, hold on a minute, I see exactly where your data is. Okay, now send me more. And each new piece that gets sent in either gets stored in another area, or the SAN first says, let me copy off those old blocks and overwrite the new stuff. It works, and I'm not going to go into too much detail here, but the thing to know is, if you ever want to do this, you have to design from it from the get-go, because your SAN vendor will have rules on whether or not data and log files can be on the same drive, whether different databases can share the same drive letter, and how those snapshots are made. Overall, and only want to use the dedicated LUNs for data and logs if I can do things like tiered storage, so we talked about earlier. Yes, go ahead. Mount points, or to say, actually it's funny, I have a really small note down there in the bottom. I say, yes, smart guy, I'm simplifying this. You tried teaching virtualization and SANs in 75 minutes to SQL Server DBAs. It's hard, not because you guys aren't smart, but mount points is exactly the same thing as a LUN. I'm simplifying it, people. You earn a gold star because you're the smartest guy in the room. Except for Robert Davis in the front row, Microsoft Certified Master. Did you get your little thing that said Microsoft Certified Master?
Not yet.
Oh, golly. I should give you mine. So because we're a little bit short on time, I'm going to jump a little bit forward, and I want to dwell on this one point. Until you can prove that the connectivity between your server and the SAN is not the bottleneck, stop writing checks. Over and over and over. I go into performance tuning engagements and people keep shoveling money into the SAN like it's a train, and they're shoveling coal into it going, give me another 10 drives, I need more performance. And the reality is that you're using things like iSCSI that's capped at 1 gig of throughput, or Fiber Channel that's only 2 gigs or 4 gigs, and you can saturate that with a handful of drives. The bottleneck, 9 times out of 10 when I'm doing tuning, if you haven't thought about pathing before, this is going to be your bottleneck. And I explain this in my lightning talk today later on. So the 2 links to cover everything that we've talked about here, brentozar.com/go/SAN and brentozar.com/go/virtual. Don't pretend like you're writing it down. You're going, I'm never going to this guy's session again. Make sure I don't do this. everything that we covered today. I covered how virtualization changes CPU, memory, and monitoring. It also changes storage and high availability disaster recovery. We talked about, but I don't cover those here. I'll cover them over on my blog. And how SQL Server, you should focus on the guidelines from your vendor, not from bozos like me who get up and speak in front of audiences. Complete your evaluation forms. Speakers take this insanely seriously. We really value your feedback. And just because you think I suck and you think I'm going to ignore your advice, you're wrong. There are other people who want to hear how bad I suck so that I never get invited back here to speak again. Finally, in case you're one of the crazy people who actually believe that I was worth seeing, these are some of the other things that I'm up to this week. Today at 1 o'clock, I'm doing a book signing. If you've got my book, or you can buy a copy, there's 7 of us who wrote Professional SQL Server 2008 Internals and Troubleshooting. For the first time since the book was published, all 7 of us are going to be in the same place at the same time. And if you want to kill us for how bad the book sucked, now's your time. Come in with a gun and just mow us all down at once. At 3 o'clock, I'm doing a lightning talk. In room 301, we have a series. Buck Woody is also going to be doing one. They're 5-minute presentations. To talk for exactly 5 minutes, and then they yank us off the stage. And there's almost no words in my slides, which should be very fun. And then finally, at 4:30 today, Buck Woody and I are doing one called You're Not Attractive, But Your Presentations Can Be, where we're going to cover how to do presentations and get spotlight sessions at PASS. So I want to thank all of you for coming into my session and putting up with my stuff, and now you're free to go and go get your money's worth from the other people. Thank you. You're too kind, you're too kind. What's that?